Hi y'all, this is lecture 9 on 2.7 quadratic inequalities. So now that we've solved inequalities, now we're linear, meaning our x had a power of 1, now we want to talk about, solving quadratics solving inequalities that have quadratic terms, so x squared terms. And so with solving quadratic inequalities, we require some of the same tricks that we use to solve quadratic equalities, except that we must take care with negatives, and we cannot assume that if x minus a times x minus b is less than 0, then that's the same as one of them has to be less than 0, okay? So this gets a little bit more complicated, not by a lot, but it does get a little more complicated. So here's how we handle this. So whenever we're solving quadratic inequalities, my thought process is going to be this. Number 1, solve the equation to find the endpoints. Number 2, we're going to create intervals. And number 3, we're going to test the intervals in the inequality. Okay, so that's what we're going to do. So let's take a look at example 1. We're going to solve 3x squared minus x is less than or equal to 4. So the first thing I'm going to do is I'm going to think of this as if it were an equation, okay? So I'm going to set it equal to 0. So I'm going to subtract 4 from both sides. So that means we're working with 3x squared minus x minus 4 is less than or equal to 0, okay? Now, what I'm going to do is I'm going to pretend that it's not less than. I'm going to pretend that it's equal to. So 3x squared minus x minus 4 equals 0, okay? And now I'm going to solve this, okay? Now this one I think is factorable. Let's check it. With the 3x squared, I'm going to go box and circle. So 3x squared here, negative 4 here, which means I get a negative 12 in my circle, and I need to add or subtract, I need to add to negative 1. So two numbers that multiply to negative 12, but add to negative 1 are going to be negative 4 and positive 3. Each one of those gets an x, and we factor the box. You can see that the column on the left has a common 3x, and the column on the right has a negative 4. When you take all that out, in the first row, there's a common x there to make it work, and a 1 to make it work on the bottom row. And so that means that this is going to factor as 3x minus 4 and x plus 1. Okay. From here, I set each piece equal to 0. So this one becomes 3x minus 4 equals 0. And we'll add 4, divide by 3. So add 4, divide by 3. And over here, this one will have x plus 1 equals 0. We'll subtract 1 to the other side, and we get x is equal to negative 1. So now I have 2 points, okay, 2 x values. And what that's going to do is going to create the endpoints for my interval. So what I'm going to do now is I'm going to set up intervals. So I'm going to break up my number line. So I'm going to think about a number line. And I'm going to put 4/3 on it and negative 1. Okay. So if I'm thinking about the corresponding intervals, actually, let's do it on the number line. Okay. So let's choose a number that is to the left of 4/3. So something that would be over here. Okay. So something over here, something less than 4/3. How about, oh, wait, hold on. Let's try to do this right. If I create my number line, negative 1 goes over here because it's smaller, and 4/3 goes over here because it's larger, right? Because that's a little over 1. Now let's try. So now we need a number that is smaller than negative 1. So I would pick negative 2. And I'm going to plug negative 2 into the original inequality, this one right here. So does negative 2 make this work? So if I do that, so if x equals negative 2, what happens? We get 3 times negative 2 squared minus negative 2 minus 4. So that is 3 times 4 plus 2 minus 4, and this is 12 plus 2 minus 4, which is 10. And we want it to be less than or equal to 0. Is that true? No, 10 is definitely not less than or equal to 0. So this is not the, whoops. This is not the interval we want. Okay. Then we check something in between. So between -1 and 4/3, I'm going to pick 0. If I pick 0 and plug it in, that's going to give me 3 times 0 minus 4. And that's just going to be -4. Is that less than or equal to 0? Yes. So that means, yes, we want this interval right here. Okay, now it's or equal to, so I'm going to include my endpoints, right? So I definitely want this section right here. Okay. Do I want the section on the right? Do I want this one? Well, let's check it. I need a number that's bigger than 4/3. So how about the number 2? We're going to take 3 times 2 squared minus 2 minus 4 and see what happens. Is that less than or equal to 0? So this would be 12 minus 2 minus 4. 12 minus 2 is 10. 10 minus 4 is 6. Is that less than or equal to 0? No, it's not. So we're not going to use that interval either. So the only interval that's going to work here is we're going to include our endpoints. Because if we check -1 and 4/3, it'll be equal to 0. And we want the space in between. So our answer here is going to be, we want -1 to 4/3. And we're going to include each endpoint. Okay, so you have to find your endpoints, create your intervals on the number line, and test each interval in the inequality to see if it works. Okay, let's do another one. Here we go. 25x squared minus 16 is greater than 0. So this one is already set equal to 0. So I have 25x squared minus 16 is greater than 0. This one is factorable. So let's go ahead and, so we're going to solve the equation. 25x squared minus 16 equals 0. And this one I can factor. It's a difference of 2 squares. So I get 5x minus 4 and 5x plus 4. And that means my two solutions are, we're going to set each piece equal to 0. So 5x minus 4 equals 0. So we add 4 to both sides and divide by 5. And this one will give me 5x plus 4 equals 0. And we will take and subtract 4 to the other side and divide by 5. So that gives me two solutions to the equation, 5/4 and -5/4. So let me set up my number line here. -4/5 and +4/5. And I'm going to check a number in each section. So over here, I'm going to check x equals -1, right? Because 4/5 is less than 1, so I can choose -1 over here. And if we plug that in, that's 25 times -1 squared minus 16, and is that greater than 0? Well, that's 25 minus 16, which is in fact greater than 0, so that one works. So I want that one. Okay, now, if I'm shading it in on my number line, this is strictly greater than, so I use open circles at both points, and I definitely want this part over here. Okay, so that part works. In the middle, I'm going to choose 0. I always choose 0 when I can because it makes my life easier. So 25 times 0 squared is 0 minus 16. Is that greater than 0? Well, that's going to give me -16 is greater than 0, and that is not true. So we don't get the interval in the middle. Okay, and then we're going to choose a number on this right side. So I'm going to choose x equals 1. If I plug in 1, that's 25 times 1 minus 16. Is that greater than 0? Well, 25 minus 16 is 9. So that is greater than 0. So this one also works. So I also want this section over here. And then we turn it into intervals. So my solution, I want to go from -infinity, which is what the arrow means on the left. I want to go all the way up to -4/5, but I don't include it, right? Because it's open circle. no or equal to. Then I'm going to jump to the second blue arrow there, and that starts at 4/5 but does not include it, so use parenthesis, and goes all the way. The arrow means go to positive infinity, and I use a parenthesis on that one as well. So here is my final answer. Okay. All right, here we go. Number 3, same kind of thing. Okay. Find all solutions for x squared times x plus 1 is greater than or equal to 0. Okay, so this one is already set equal to 0, so I can start. I've got x squared times x plus 1. I'm just writing it a little bit bigger so I have it ready to go. And I'm going to start over here on the left by solving it as an equation. So set it equal to 0. And this is already factored. This one gives me x squared equals 0. And this one gives me x plus 1 equals 0. If you take the square root of both sides, this is just x equals 0. And over here, we're subtracting 1 from both sides. That will give me x equals -1. So I have 2 points to work from. I have 0 and, whoops, and -1. -1 is smaller, so it goes on the left. 0 on the right. And we're going to choose numbers. Now, this is or equal to here, so we're going to use closed circles at our endpoints. Right. And we're going to choose numbers in between. So something smaller than x equals -1 would be x equals -2. If I plug that in to the equation right up above there, we're going to take -2 and square it times -2 plus 1 and say, is that greater than 0? -2 squared is +4. -2 plus 1 is -1. And that's going to be -4 on the left. Is that greater than or equal to 0? No. So I don't want that first section. Between -1 and 0, I'm going to go with x equals -1/2, right? There's no whole numbers between -1 and 0, so I've got to choose something that's a fraction. So let's go with -1/2. Then we're going to take -1/2 and square it, and then -1/2 plus 1, and say, is that greater than 0? Well, if we square -1/2, that becomes +1/4. -1/2 plus 1 is +1/2. And when you multiply those two fractions, we can multiply across, so 1/8. And is that statement true? Is 1/8 greater than or equal to 0? Yes. So that means I do want the section between. And then lastly, I want a number bigger than 0. So if we make this is not 0, but 1, that would qualify. And we're plugging into our inequality here. So 1 squared times 1 plus 1 is greater than or equal to 0. So let's see. This gives us 1 times 2. Is that, I put the question mark up above because we're not sure yet. 1 times 2 is 2. Is that greater than or equal to 0? Yes. So we also want this section. So that means we want to start at -1, and we're going to go all the way through to the arrow. So that goes all the way to the infinity, and I'm going to use a square bracket because I want to include my endpoint because it's a closed circle and it's greater than or equal to. And so I get the whole interval from -1 to infinity. All right, now we can take a similar approach to solving inequalities involving fractions. Just remember that the denominator cannot equal 0. So we're going to find all solutions here and illustrate them on a number line. Okay, so we're going to do exactly the same thing. So let's see, we've got x squared minus x all over x squared to, plus 2x is less than or equal to 0. Now, the first thing I'm going to check is what answers am I not allowed to have? So if I take a look here at the denominator and say what numbers do not work in here? Well, this does not, I cannot have 0 in the denominator. So I'm going to take my x squared plus 2x and say, okay, where are the points that are equal to 0? If we factor this quadratic and set each piece equal to 0, x equals 0 is a number that won't work. That is not in the domain of this function. And if I subtract the 2 to the other side, this will give me x equals -2. So x equals 0 and x equals -2 when plugged in here are not going to work. All right. So what do we want to do next? Well, we're going to keep that in mind, but we're going to go ahead and solve this the same way that we did the others. So I'm going to pretend that instead of an inequality, I have an equal sign here. And what we would do is we would go ahead and multiply by the denominator. So we'd multiply by x squared plus 2x. What that does is we're going to have x squared minus x times x squared plus 2x equals 0 because it cancels. Oh, sorry. Oops. We are going to, on the left-hand side, it cancels, and I'm left with just the x squared minus x. And on the right-hand side, anything times 0 is 0, so we just get 0. So that means if I factor this out, this will give me x times x minus 1. And we have, this one will give me x equals 0. And this one will give me x equals 1. Okay, so what I'm going to do is I'm going to take all 4 of these points just to be safe, and I'm going to put them on my number line. So I've got -2, 0, and 1. Okay. All right, now we know right away that we cannot get 0 or -2. So I'm automatically going to put a circle around 0 and a circle around -2. Now, because the equation up here is less than or equal to, for the remaining number for 1, I'm going to make that a closed circle. Okay, so just to be clear, the points that we found in the denominator that are not okay are the ones we put open circles on. I'm not allowed to have a 0. I'm not allowed to have a -2. So a circle around those. But all other points that I found, I'm going to color in because of the or equal to right here. Okay, and now we're going to go ahead and test our intervals. So I'm going to choose a number less than -2. So let's go with -3. So if I plug in -3, I'm going to take a -3 and square it. Minus -3 divided by -3 squared plus 2 times -3. And let's see, we get 9 plus 3 over 9 minus 6. And that's going to give me 12 over 3, which is 4. And we want to know, is that less than or equal to 0? And the answer here is no. That's not true. So I don't want this first interval. Okay. So let's check a number in between -2 and 0. So let's go with -1. And we plug into the same thing. So we're going to square -1 minus -1 up top, square -1 plus 2 times -1 in the bottom. This will give us 1 plus 1 over 1 minus 2. That will give me 2 over -1. So this is -2. And the question is that less than or equal to 0? Yes. So I do want this section here between -2 and 0. Then I choose a number in the next section. So I want x equals positive 1/2 between 0 and 1. And we plug it in. So 1/2 squared minus 1/2 and 1/2 squared plus 2 times 1/2. This is going to give me 1/4 minus 1/2 all over 1/4 plus 1. Let's see, 1/4 minus 1/2 is minus 1/4. And on the bottom, we have 3/4. Nope, 5/4. So that will reduce. You can cancel the 4s on the bottom to -1 over 5. If you don't like that, use a calculator. Check it. Is that less than or equal to 0? Yes. So we also want this interval. And then let's check that last one. If I have x equals 2 and I plug it in, I'm going to have 4 minus 2 and 4 plus 4. So that's going to give me 2 over 8. And the question is that less than or equal to 0? No, because it's positive. So I don't want this last one. So I want those two middle ones. But notice I can't have 0. So what that looks like is parentheses at -2, all the way to 0, stop, pick back up at 0, go all the way to 1, but this time I'm going to include my 1. So this is my solution. And let's take a look at one last one. So same idea here. So first thing we want to do is to decide which numbers we're not allowed to have. So we're going to take a look at the denominator, the 3x plus 5, and set that equal to 0. So we're going to go ahead and subtract 5 and divide by 3. So this tells me that x equals negative 5/3 is not a good answer. Okay, we're not allowed to have it. So we're going to exclude that on our number line. So that means when I draw my number line, actually I'm not going to put it on there yet because I want to see what else is going to go on there. Okay, so now we are going to go ahead and take our inequality here. So x minus 2 over 3x plus 5 is greater than 2. And we're going to pretend that it's not an inequality. We're going to make it an equation, and we're going to solve. So let's multiply both sides by 3x plus 5. When we do that, we get x minus 2 on the left because it cancels, and we get 2 times 3x plus 5 on the right. That gives us x minus 2 equals, distribute here, so we get 6x plus 10. Then we're going to subtract our x and subtract our 10. And that's going to give me negative 12 equals 5x. Divide by 5, and we get x equals negative 12 divided by 5. Okay, and that's going to be negative 2 2/5 if you like to figure that part out. If you want to go to decimals, that is negative 2.4. Okay. All right, so now to our number line. I have negative 5/3, which is negative 1 2/3, and negative 2.4. So negative 12/5 is over here, and negative 5/3 is over here. If you need the decimal equivalence, this is negative 2.4, and this one is approximately negative 1.67. Okay. So now we need to, so first of all, let's look at whether we're open, closed circle, or closed circle. So the one word's no good, our negative 5/3, we get an open circle automatically because we can't have that number. Then for the other numbers, we look at our inequality symbol. So we're looking here at that strictly greater than, and I'm going to put an open circle around there because there's no or equal to. Then we're going to go ahead and check 3 points. So I need something smaller than negative 2.4. So I'm going to go with x equals negative 3. Let's find our inequality. So we've got x minus 2, so negative 3 minus 2, because we're plugging into the original, over 3 times negative 3 plus 5. And we want to know, is that greater than 2? Okay. Well, this is negative 5. And on the bottom, 3 times negative 3 is negative 9. Plus 5 is negative 4. So this is 5 over 4. Is that greater than 2? Well, if you multiply both sides by 4, you get 5 is greater than 8. Is that true? No. So I don't want this first section. No go. Okay, so let's check a number between. So a number between negative 2.4 and negative 1.67 would be negative 2. And let's plug it in. So negative 2 minus 2 over 3 times negative 2 plus 5. And we want to know, is that greater than 2? So that gives me negative 4. And on the bottom, 3 times negative 2 is negative 6 plus 5. So this is negative 4 over negative 1, so positive 4. Is that greater than 2? Yes. Okay, so that means we do want the space between them. Then we check something larger than negative 5 over 3. So 1 second. 1 second. I'm recording a video. Let's go with 0. So if we plug in 0, this is 0 minus 2 and 3 times 0 plus 5. And is that greater than 2? So if we do this, this is negative 2 over 5. And is that greater than 2? If you multiply both sides by 5, that's negative 2 is greater than 10, and that is not true, right? And so this is a no. So we don't want that second interval. So all we want is the interval in between, and that's going to go from negative 12 over 5 to negative 5 over 3, and we're going to use parentheses on both sides because we're not including. Okay.